This week we're going to look at ways that you can cut down file size on images you save from Matplotlib. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer for Unidata. This week we're going to look at something that every meteorologist loves, maps, and how we can make the map file size smaller, which is something that every IT professional loves. So while hard drives may be relatively inexpensive now, and bandwidth is pretty plentiful, there are still good reasons that you might want to try to reduce the file size on maps that you're making. For example, if you are making a lot of maps, say for your research, using a WRF or plotting decades of GFS output or anything else that's going to make a lot of images, you're going to need a lot of storage space, especially if you're going to upload those to a cloud storage service where you're paying by the space that you're using. Now, you may not need full resolution. You may not need giant images. In fact, if you're making images for many parameters a day, it's probably more than you're going to look through. You're going to try to find interesting time windows and go look at those. You're just coding to make maps for all the available data because, well, that's the easiest thing to do. Here I've got an example 500 HPA map that's from the Python examples gallery. So we're not going to go over the code for it. It's relatively straightforward, getting some test data and making this plot. But what I'm most interested in is how can I save this plot in different ways, and what does that do to my image size? So for one thing is we could make the plot smaller. We could save a smaller figure just by looking at fig size 14 by 12 inches at the default DPI is probably a lot larger than you need. Maybe not, depending on your application, but that would be one way to save file size is to scrunch that fig size down. But for now, we've saved this as map.png using savefig. So I'm going to add a few cells down here. And then from pathlib, I'm going to import the path object. And I'm going to print original map. I want my path object for map.png .stat .st size, divide that by 1024, print it as a floating point with 1 decimal place of precision, kilobytes. Oh, and I've got a extra curly brace there. All right, so our original map is 552K, or about a half a meg. Now, again, that's not a giant file, but if you've got 200,000 of them, that can add up pretty quickly. Now, if we look at this map, we see it's got this big white border around it that we don't need. That's just because of the aspect ratio we specified for the image and fig size. And maybe you need that for your application, but more than likely it's not. It's just taking up extra storage space. So let's clip that off and see how much that helps. So to do that, I'm going to go back up here to our savefig call. I'm going to specify that our bounding box in inches is tight, meaning just make the box that we're saving as big as we need for this image. Oh, except I want to save that as something different. So let's save our original map first. Put that back in, and let's call this map clipped.png. And while that's running, I'm going to go ahead and look at clipped map. So 529K. So 30K of savings. Not nothing, but not impressive. But if we look at the image now, we see that there's not really any extra white space around it as before the clipping. So that's probably a good thing for whatever you're doing. But it's not going to save you a lot of space. Now, I did a little bit of research on different ways to do this, but there's lots of recommendations out there on the internet, right? Everybody's got an opinion. So we need to test some of these opinions and see what's going to work the best. I'm going to use the Python image library and use it to convert these images to different color palettes, different color spaces. There's, of course, a Python wrapper for ImageMagick that you could do this in as well, but I like staying in pure Python if possible. So from PIL, I'm going to import image. And actually in the same cell, let's go ahead and open image.open mapclipped.png. Okay, so now I'm going to have image 2 as a handle. And this is the first suggestion that I found while reading about using PIL to try to reduce PNG file size, which is to convert to the RGB color space, which I thought was an odd step because, well, matplotlib is already saving things in the RGB color space. But okay, let's follow the recommendation. Then I'm going to call convert again, so I'm chaining these. I'm converting the palette. And they recommended using the adaptive palette, which there was quite a few details in the documentation. Then we call image2.save, map clipped converted RGB adaptive.png. And as you see, that happened almost instantly. So clipped map, RGB, and adaptive converted. And it was called map clip converted RGB adaptive. 182K. So that's over a 300K reduction. That's significant. That's relatively impressive as well. If we were to open up this image, it really looks just as good as the other one. So here's image 1 and 2 flipping back and forth. I can't really tell any difference. We can zoom in. Again, I can't really tell any difference between the images. I even brought them into Adobe Illustrator and looked. It was very hard to tell any difference. There was a slight size difference, but again, I didn't really see any quality changes. Okay, so that's good, but let's keep experimenting. So I looked in the documentation for convert, because you should always look at documentation before you blindly paste commands off of Stack Overflow. And I saw there's a web palette. Well, a lot of us are posting images on websites, so I thought, well, let's try the web palette. Again, we'll copy and paste. This is web converted. $175K. So some reduction, not a lot, but let's look at the image. This one, there is a significant difference. See all these artifacts, even down here in the color bar. So this was not a good conversion. We saved a few K, but at great expense to our image quality. And then I wanted to try one more thing because, well, we're already in the RGB color space. Why do I need to convert to the RGB color space again? Let's delete that. And let's just convert it straight to the adaptive palette. That's the one that seems like it's working for us. Okay, so this is not RGB, it's just adaptive. converted. $128K. So we've gone from 552K for the original image all the way down to 128K. That's a massive space savings. Let's take a look. And this is clip converted adaptive. And again, I just don't really see any major differences in this image. So by using the image library, we're able to change the palette on this image and save many times the file size that comes out of matplotlib. So again, if you're just making a few images, it's probably not that big of a deal. But if you're running a lot of images for your research, making hundreds of thousands of images, especially if you're uploading them somewhere, or they're being utilized over a low bandwidth connection, say pulled up on a cell phone, well, this is a great way to save some space for very little effort. I hope that you found this useful, and I'll see you on next week's MetPy Monday.